Okay, everybody, let's do a recap of the lesson today. So we are on page 292, and it's lesson 3.3 of this stuff. So we're talking about inequalities, and so this is a nice example of why you have to turn the sign, because we talked about that yesterday. So here's our example. Alan's camping troop hikes down from the campsite at an elevation of 4,800 feet. Right there, that's our start. Down to the base of the mountain, which is at sea level, at 0, okay? They hike down at a rate of 20 feet per minute. So they're hiking down, and as time goes on, they go further down the mountain, okay? So then they give us an equation, y equals, I like y equals mx plus b. That's the best way to start. There's my slope. It's negative because we're going down. Y equals a negative 20x plus my 4,800. Now, the book wants us to use h of n, height per minute. I can do that, so I just change my variable c. H of n, or height per minute, equals negative 20m plus 4,800. That describes this line, okay? We know then the independent variable has to be time in terms of minutes. We can control the time, and then the elevation is the dependent variable, because whatever time you are at, that depends on the time. So that's my dependent variable, which is elevation. The slope is negative 20. We know that, so it's negative 20 feet per minute. The y-intercept is 4,800 feet, which is the beginning height, and then we start hiking down from there. The x-intercept, if we look at the graph, is at 240, 0, and the domain. Now the domain is normally the x values, but in this case it's time in terms of minutes, so it is from 0 to 240. That's our domain. So we wrote it like this. Our time is in between 0 to 240 minutes, which represents all of the time that we're hiking. We're hiking from 0 to 240 minutes. That's our domain, okay? And of course we changed it to m because that's the variable they wanted us to use, m for minutes, okay? Now, if we want to talk about the amount of time below 3,200 feet, how much time is below 3,200 feet? I just drew a line straight across at 3,200 feet. So up here is our time above 3,200 feet, and this is our time below 3,200 feet. So then we take a look at the problem. Okay, it says, all right, use the graph to determine how many minutes have left when the troop is below 3,200 feet. Draw an oval on the graph. So I can draw an oval on the graph. It's all of that time right there, okay? To represent this part of the function and write a corresponding inequality statements. Okay, right? So I got h of m. So I've got my negative 20m plus 4,800 has to be less than 3,200 feet. So then I solved it, okay? I divide minus 4,800 from both sides, minus 4,800, minus 4,800, which is 1,600. I divide by negative 20, divide by negative 20. Now if I don't turn the sign, you must turn the sign. Anytime you multiply or divide by a negative, you turn the sign. Because think about this. After 80 minutes, we're below it. Before 80 minutes, we're not. So it doesn't make sense. It has to be greater than 80 minutes. It has to be, because more than 80 minutes, we're below that, okay? If we hadn't turned the sign, it wouldn't make any sense, okay? Then we compared our chart. If our height is greater than 3,200 feet, our minutes are going to be less than 80. Okay, we just started hiking. If our height is greater than or equal to 3,200, then our minutes are going to be less than or equal to 80. Okay. If our height is exactly equal to 3,200 feet, then our minutes are at 80 minutes, exactly at 80 minutes. If our height is less than 30 minutes, then our hiking time is less than 80 minutes. And if our hiking time is less than or equal to 3,200, then obviously our minutes have to be greater than or equal to 80, okay? So what we notice about the signs is they are the opposite signs because we had to flip this sign, okay? That's all I had. I had a worksheet to go along with that, so if you have any questions, come see me.